Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study and solve some of the problems on Macaulay's method. Here, a horizontal beam AB is simply supported at A and B. It is simply supported at A and B. Apart, it is also simply supported beam. The beam is subjected to a clockwise couple of 300 kilonewton meter at a distance of 4 meters, at a distance of 4 meters from the left end. And here is the moment is acting in clockwise direction. The between supports it is AB. Between supports the length of the beam is 6 meters. Here the modulus of elasticity is 2 into 10 power 5 Newton per square millimeters, and the second moment of area of the material is of the cross section of the beam is 2 into 10 power 8 2 times millimeter per 4. Now here, what are the objectives? The objective one is deflection at the point where couple is acting. Deflection at the point where couple is acting. We want a deflection at point C. And also another objective is that the maximum deflection. So we don't know the maximum deflection, so that means we have to locate the maximum deflection value. First, the distance. After that, we have to substitute in the equation of deflection. Then the maximum deflection can be calculated. Let us begin here. Okay, one thing is that what is the difference between this problem and before session problems? In before session problems, one thing is that in first one of the problem, it is only for a considered as a overhanging beam. In the overhanging beam consists of is point load or concentrated load acting at the free end. That is the overhanging beam. Here 10 kilonewtons acted in before session, before problem. This is 6 meters and here it is 3 meters. We have to find out support A, support B, and also point load acting, that point where the load is acting, that point, that's C. So the uniqueness of that problem here, this case is, even though the reactions we considered upwards, the load is acting 10 kilonewtons, but the reaction at A, the load, the effect is that it is downwards only, it is not upward support. The reaction is not upwards. The load is acting downwards because of the effect of 10 kilonewtons at the free end of your overhanging beam. And we calculated here the slope at A, slope at B, slope at C, and also the maximum deflection and the deflection at point C for this case study. But there is another case we consider. It is overhanging beam, but the uniqueness is that here the UDL is acting, uniformly distributed load up to certain portion. It may be 6 meters here, but a 3 meters portion UDL acting, and here it is 6 meters and 12 kilonewtons load active. We have solved this type of problem, that here it is 4 kilonewtons per meter. Now the specific here, that comparison to before case 1 and case 2, here uniformly distributed load combination combined with concentrated load over a overhanging beam. Now in this case there is no direct type of loads. Here the uniqueness of this problem, the variety of this problem is that the moment is acting at point C. How much the moment is? 300 kilonewton meters. That is the uniqueness, is very important model and also very interesting here. Let us see. Here the length given 6 meters, 300 kilonewton meter, and modulus of elasticity of material is 2 into 10 power 5 Newton per square millimeters, and area moment of inertia is 2 into 10 power 8 millimeter per 4. First, what to be done? We have to calculate the reactions at supports A and B. That is RA at support A, RA at support B, RB. Now RA and RB. Now how to calculate here? No need to go for total load equal to total reactions here. Now how to calculate here? Because the total load vertically downwards is 0. Okay. So consider directly moment equation. In this moment equation, the moment equation is that RB times 6 equal to clockwise movement equal to counterclockwise movements. The clockwise movement is 300 kilonewton meters, 300 kilonewtons meter, and counterclockwise RB into 6 meters. RB into 6 equal to 300 kilonewton meter. So the reaction comes in kilonewtons. That RB value comes 50 kilonewtons. What is the reaction at A? Then RA equal to total load minus RB. Total load is 0 and RB is 50. That is minus 50 RA. You see how we consider, because of this moment, the force is acting what? The reaction itself acting downwards. The reaction is downwards acting now. Because negative value minus 50. Minus 50 kilonewtons is the positive. Alright. Now, after considering this is the RA minus negative 50, RB plus 50. Now, how to consider this bending moment? Now, equation of bending moment to be considered between the portion X. Consider this distance from where? Between C and B, X here. For that equation, bending moment equation, here it is minus, that is negative direction, here it is minus 50 times X plus 300 kilonewtons, that is 300 kilonewton meter, that is 300. Now 300 times, what will happen? There are two equations from A to A and C to X distance. That is minus 50 times X plus 300 times. If it is in movement already, 300 kilonewton meter, consider here X minus 4, the distance we considered here, that is the equation. This equation shows 300 kilonewtons meter. Then we write here at a distance X, 300 times, what is the distance here? 300 kilonewton per meter, 3 kilonewton meter, that means 300 kilonewtons acting. We want a distance, that is X minus 4. Now, if we integrate once, first integration of this moment equation, that is EI times dy by dx equal to minus 50 times x square by 2 plus C1 plus 300 times x minus 4. Now, if we integrate and again the equation 1 that comes into the deflection equation, that EIY equal to minus 50 by 2, that is 25. Okay, x cube by 3 minus 50 by 2, here it is 25, x cube by 3 plus C1x plus C2, that is 150, that is 150 x minus 4 whole cube by 3 minus, that is 150 by 3. Now after that, what to do? We have to, what to be done? We have to use, there are two constants of integration C1 and C2. That is, two boundary conditions are to be used in order to calculate the constants of integration C1 and C2. So we use first, how to select this constant, these boundary conditions. Take distances. Always slopes are 0 at the supports. A distance you take from first support, from left side onwards. At support A, x equal to 0. At support B, from left to right, that is x equal to 6 meters. So take the value and substitute. This y means deflection equation. You have to substitute deflection values in deflection equation. But consider the portions such a way that x equal to 0 related to the first portion equation. This is the first portion only. Now, and x equal to 0 and y equal to 0, the C2 becomes 0. And substitute x equal to 6 and y equal to 0 in a complete equation, then C1 comes as 200. C1 equal to 200. Substitute this C1 and C2 in the equations 1 and 2. Then we can see that complete equations of slope and deflection. Then EIY, this is the deflection equation, that is equation 3. That is EIY equal to 25 to minus 25 by 3, negative of 25 by 3 x cube plus 20 times x. That's the first portion, plus positive 150 times x minus 4 whole square. Now, coming to this is the equation. For every problem, by using Macaulay's method, we have to calculate which method we used here. Macaulay's method. We are using here Macaulay's method. Now we have to go for solving the objectives which were given in the problem. Now what is the objective 1? The objective 1 here, it is deflection at C. Deflection at C, that is YC. So up to, that means that is related to x equal to 4 meters. So up to 4 meters means we have to use which portion? We have to go for the equation of, that is first portion you have to consider. This is the first portion. That is minus 25 by 3 x cube. What is the x value? 4 meters. 4 cube plus 200 times x, 4. This is kilonewton meter cube. Convert to maintain the dimensional homogeneity. Convert kilonewtons to newtons, meters to millimeters, because E and Y are in newtons and millimeters. The unit for I is Newton per square millimeter. Unit for E, modulus of velocity, is Newton per square millimeter here. And the second moment of area of I in this problem is given as millimeter per 4 in the units. That's why we need the units of either millimeters or meters, either kilonewtons or newtons. So we use it here kilonewtons, we use it here newtons and millimeters. So convert this kilonewton meter cube into Newton millimeter cube. That value obtained in terms of Newton millimeter cube is 266.67 times 10 power 12 Newton millimeter cube. Now substitute by IEI. What is the E value? 2 power 10 power 5. I value 2 times 10 power 8. After substituting the values of E and I, the deflection obtained at point C is 6.66 millimeters positive. The positive means upward direction, not downward. The positive means upward direction. Negative means downward direction. So at C, it is upward. Okay. Next, we want maximum deflection value. How to calculate the maximum deflection value? The maximum deflection we want to find out. First we have to locate the location of the deflection, maximum deflection. So where the maximum deflection comes, there slope is 0. That means equation of slope, that is equation 1 equal to 0. After substituting the constant of integration C1. So after substituting the constant of integration, that is C1, that we considering here the maximum deflection takes place in the larger segment portion, that is A to C, AC portion. So where is the AC portion? It is the 4 meters. That's why we have to consider the deflection equation. Where is the deflection here? EI times dy by dx. Deflection, this is the portion, consider it. There you substitute what? This equal to 0. What is the C1 value considered? 200. So equate, that is minus 50 by 2 x square plus 200 equal to 0. From this x value, the x value is 2 root 2 meters. So x equal to 2 root 2 meters. What is the value? 2 times root 2 is up to the dotted line. Yes, equation 3. So we get the 2 times 2 point, what is the root 2 value? 1.414. So 2 times 1.414. So it comes portion between A to C. So use the first portion, that is maximum deflection, substitute here. What is the deflection value? That is minus 25 by 3 x cube plus the equation for, that is EI time minus 25 by 3 x cube plus 200 times x. In this value x equal to 2 root 2, substitute and convert it into Newton's Newtons and millimeters in the form of Newton millimeters units, and substitute E and Y values also. Then Y maximum comes as 9.48 millimeters. Yeah, it is upwards. The diffraction becomes upwards. So the Y maximum is also upwards. So the portion, if you draw the diagram, upwards deflection curve, the deflection curve at the 2 points are upwards here. Here you see here at point C it is upwards, and also here upwards. The deflection curve comes in this manner up to the point B. At 2 point x equal to 2 root 2 meters, upwards, and also at point C, what we calculated here, at point C also 6.66 meters. At point C also upward it is 6.66 what? Millimeters or meters? Millimeters. Mm. At Y maximum 9.428 millimeters. If the maximum here it is 9.428, like that comes. Here it is maximum coming down, here it is suppose. In this the deflection curve is being changed. So far we covered completely the portions of, slope and deflections are calculated for various sections of the beams by using very simple method, very simple method and easy method, that is Macaulay's method. And for all types of loads, point load also we consider, and also we calculated for UDL, uniformly distributed load, and combination of concentrated load plus uniformly distributed load for a simply supported beam and also for a overhanging beam. So by understanding, by solving these problems, or after hearing this class or attending this class, you can understand better the easiness of the Macaulay's method in relation to the double integration method. Now you may get doubt that there is another method. That method is moment of area method. So here in this, what is the difference? If you understand, for simplification more and more, just a glimpse, introduction. Okay, what is the difference between this double integration method and Macaulay's method? Yeah, double integration method easiness, very easy for a beam is having a point load or concentrated load at the midpoint. When a point load is acting at the midpoint, at mid portion of the beam, then it is easy double integration. But if you use for concentrated loads, when concentrated loads are coming to the eccentric load is coming to the picture of a either simply supported beam or overhanging beam, the double integration method is so complicated. So why it is so complicated? Because the way we have to consider the moment bending equation, and we have to consider the individual portions and deflection values, we have to equate the deflection equations. So complex and lengthy. Whereas in the case of Macaulay's method, only one, it is not difficulty. By practice you can understand. We have to write down bending moment equation at a particular section portion, and consider or select the particular portion such a way that the x value involves throughout the portion of the beam, throughout the span of the beam. So here point is that, so that's why we solved more problems by using Macaulay's method. So simple, methodology is very simple. The first step in this method we considered here, what to be found. Let it become a summary. In summary manner, I am going to disclose here how to write in summarizing what are the steps involved in solving Macaulay's method. So the steps involved in Macaulay's method. If you understand this methodology, these steps are to be applied for any type of problem, then you can get it right results. What is the step 1 here? The step 1 is that we have to find out the support reactions, the reaction supports, the values of reactions. By using the concepts of shear force diagrams and bending moment diagrams. What are they? Again, sigma Fy, vertical force, algebraic sum of vertical reactions, equal to 0. Second equation is moment equilibrium. Next, second step. After that, select a section and write down bending moment equation mx. Equate mx equation to the bending moment variation at any section x, that is ei times t square y by dx square. The fourth point is that integrate the bending moment equations. Integrate the bending moment equation mx. Integrate the mx equation, that is bending moment equation, to obtain the slope equation. Next, integrate the slope equation. Fifth step is integrate the slope equation, that is dy by dx equation. Then what will be obtained here? Deflection equation will be obtained. The deflection equation consists of, next step, deflection equation consists of, the y equation, deflection equation consists of two constants of integration, C1 and C2. Whereas the slope equation consists of one constant of integration. These two constants of integration, C1 and C2, are calculated by using two boundary conditions. What are the boundary conditions are? In that again, A, at first support you take from left side, you pass on x equal to 0, the deflection equal to 0. The second boundary condition is x equal to 0, x equal to at some distance up to the L between two supports, another support, that is L, for the deflection y. So by using here these two boundary conditions, we can calculate the values of C1 and C2. Substitute this C1 and C2 in again back the deflection slope equations. That has to be done for every problem. Then go for objectives. In the objectives, whatever they will ask. If they ask at supports, find out the x value. What is the support, that x value? That support, any support, anywhere you can find out. So based on the x values, after that substituting C1 and C2, we'll get the generic equations or parametric equations of slope and deflections. In that, by substituting x value, different values of various values of x, we'll get a particular value, what is the slope and what is the deflection. Alright, it is so simple and easy. And why should we use this? One more thing, Macaulay's method. Why should we use a double integration method? Yeah, these are the methods are useful in order to find out the effect of loads and how the beam is being deflected. Mainly, we are going to calculate the deflection values. Mainly, we'll calculate the slope and deflection values of the beam throughout its span. You may feel that the supports, there are some supports we observed here in the sessions, in before session and in this session. The support A and support B we considered as the reactions are upwards. Why we consider the reaction is upwards? Because the load at the beam at the free end for the overhanging beam is acting downwards. But after calculating, we understood the effect of the downward force. The reactions also it is acting. The reaction is not acting upwards. That force is causing downwards. That reaction is acting. That force is affecting downwards only. So that's why these calculations are very, very important in order to construct any heavy structures. Otherwise, it yields. We may think the effect of load is, it is downwards, the constant load is downwards, but the reactions are upwards. These two reactions are supporting. Here, that's what we saw here. What is the effect of, in this case, the value of RA, we obtain here negative value, negative minus 50 kilonewtons. But after calculating, what is the direction of the reaction? Negative minus 50 downwards. Because of this moment 300 kilonewton meter, only support, which one is reaction force is coming here, 50 kilonewtons it is acting. And what about here the reaction at A? It is not down upwards, it is downwards. After calculating, we got to know what is the effect of that force, the direction of the effect of the force at support A. Because of the movement, even though the movement is clockwise, we consider here. Suppose if the movement is counterclockwise, how it will affect? So the directions are so important in order to calculate the reactions at the supports and also deflections and the slopes. So the physical significance of the deflection indicates when the load is acted on the beam, when the load is acting on the beam, the beam is going to be deflected. Suppose if the person is, there is a, near the swimming pool, there are two supports. The person who is standing here to jump, to drive into the water. What will happen? The beam, because of this load at the beam, it got deflected downwards. For a cantilever beam, the maximum deflection takes place if the load is acting at the free end. The deflection is maximum where? At the free end. What is the deflection at the fixed? Zero. There is no deflection at the fixed end. So it acts, the deflection leads. So the deflection is having certain limit. It should not overtake. If it crosses the maximum deflection, the fracture takes place, failure. So the deflection should be within the limits. But we have the portion such a way that here in these sessions we are studying here only calculation of how to calculate the slope and deflections of the beam at various supports. So here, that is the importance of the slope and the deflections. Now, in this session or in before session also, we considered there are three unique models for a overhanging beam and simply supported beam. For a when the beam is acted by concentrated load and also uniformly distributed load, and also combination of uniformly distributed load and concentrated load. And one more, in this session we considered only there is no concentrated load and there is no uniform UDL, uniformly distributed load, and there is no uniformly varying loads. Considered only moment. The moment also acted here. The moment also acted here in this clockwise direction with the value of 300 kilonewtons. So these are the methods, and one more method is there. There are various methods. One more method is moment area method. So each and every method has a particular advantages and particular disadvantages, merits and demerits. But Macaulay's method is highly useful in comparison to other methods. That's what so far. Now we will see after applying the moment area method how to go for. But in the case of moment area method having their own easiness. Okay, we'll study in the next session what is moment of area method. So the references are followed for this session. Yes, these are the references followed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.